Good morning, good afternoon, and good evening. This is Mr. Payne bringing you Introduction to Sequences. This is our new topic for this unit. A sequence is a very special type of function. When students first encounter sequences, they often think of them as just a list of numbers in some particular order, and then they have to find a pattern. We will start with the technical definition of a sequence in terms of a function. So, sequence definition. A sequence is a function whose set of inputs, the domain, is a subset of natural numbers. Example 1, 2, 3, 4. A sequence is often shown as an ordered list of numbers called the terms or elements of a sequence. Sequence function notation can be a little tricky. I do have some good tricks to understand sequencing and figuring out your terms. So just stick with me and give it a good try. We will spend a lot of time on this. The first two things that I want you to underline are the words terms and elements in that definition. Those are our vocab words. Now let's look at exercise number 1. Consider the sequence below. If we represent the sequence with the letter A, then do the following. A couple things that I want us to work on right away is that I have this sequence of numbers. I want us to understand that 4 is term 1, 8 is term 2, 16 is term 3, 64 is term 4, 128 is term 5, 256 is term 6. If we do that right away, that makes our life a lot easier. Now let's go ahead and understand what A is asking us. A says find, now listen to the wording, A sub 3. What does A sub 3 mean? That means the third term. So what is the third term? The third term is 16. Let's look at B. It says find A sub 1 plus A sub 7. So A sub 1, what is the first term? It's 4. Plus A sub 7. And I apologize. I made a mistake in the notes. Well, there should be a 32. There should be a 32 in there. So let's go in there real quick and let's edit that as we speak. Should be 16, 32, comma. And what that's going to do is that's going to screw that up. So let's go ahead and just delete that real quick. Oop, deleted the wrong thing again. So when we go through this, this is sub 1, or term 1, term 2, term 3, term 4, term 5, term 6, term 7. I apologize. So find A sub 3. A sub 3 is still 16. A sub 1 is 4, plus A sub 7, which is 256, which is going to give me a final answer of 260. Find, this is another way of writing A sub 2. Just another way of writing this. So A sub 2 is 8. Now I would like you to hit pause, and I would like you to do D, E, and I will do F. So I want you to do D and E on your own and come ready to class with those answers. F says solve for n. A sub n equals 128. Let's go up into our green line here. And where is 128? Well, 128 is here. What is my nth term? It is 6. So A sub n is 6. So my answer is A sub 6. And you can write it either way. Sequences are functions. The key here is that the input is simply the numbers placed in line, and the output is the actual number in the list. Exercise number 2. Consider the sequence defined by the formula A sub n equals 2n plus 1. Write out the first 5 elements of the sequence. So the key here is input and output. We've talked about this several times in the last couple weeks about input. My input is going to be my x value, and my output is going to be my y value. It says the first 5 elements. So I'm going to say 1, 2, 3, 4, and 5 are my elements. I'm going to take my elements, my x, and plug them into my function. When I get my answer, that'll be my output. So 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. My output is 3. I am going to input 2 to my function. 2 times 2 is 4, plus 1 is 5. That is my output. Now I'm going to input 3 into my function. 2 times 3 is 6, plus 1 is 7. I'm going to input 4. 2 times 4, plus 1. 2 times 4 is 8, plus 1 is 9. That is my output. I want to do input of 5, so 2 times 5, plus 1. 10 plus 1 is going to give me 11. That is my output. So input, 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 input. I put these as my output. So my first term is 3. My second term is 5. My third term is 7. My fourth term is 9. My fifth term is 11. I want you to go ahead and now graph these points just like we were graphing a normal line. So 1, 3. So I'm going to go over 1, up 3. Over 1, up 3. And put a dot. The best that you can. Yours is going to turn out nicer than mine. 2, up 5. 3, 7. 3, 7 is going to be off my graph. So I want you to go ahead and continue it. And I want you to graph that sequence. However, I do not want you to draw a line. We'll take care of that and talk about that in class. I'd like you now to look at D. D says, what is the 21st term of the sequence? Show how you arrived at your answer. Well, you could just extend this graph and keep going all the way to 21. Or you can take the sequence a sub n equals 2n plus 1 and say, all right, I know my a sub n. I know my n. It's telling me that my 21st term, which is my n, is 21. So a sub 21 equals 2 parenthesis 21 plus 1. 2 times 21 is 42, plus 1 is 43. So the 21st term is going to be 43.